at least in these deep hydraulically fractured wells that are 6,000 to 8,000 feet, there aren't documented issues of things leaking and coming back up through the surface from this horizontal well. What there are some documented cases is where we've had well blowouts or issues with the integrity of the cements in the casing. If you had a leak here, you can imagine if you were putting that much high pressure water and fluids down and it basically came out into the groundwater or something here, you could have an issue here. So looking at the integrity of your casing, integrity of your cements, and either pressure testing the wells or things that you could do ahead of time to basically say that this is very unlikely to occur.
Right.
There has been a few cases where that has occurred, and we've had some detrimental environmental issues with people's basically drinking water in their wells. Other things that are, I think are really of importance environmentally is when we're basically mixing these chemicals and waters at the surface that they use for hydraulic fracturing is, best practices that would help prevent any sort of contamination of water at the surface from spills and from liners within your ponds and those sort of things. I think that is a huge issue. And dealing also with produced water becomes an issue. So these wells, they'll use 5 million gallons of water to hydraulically fracture shale gas well in northern Appalachia. And they'll return, as they bring that well back under production, they'll return probably 25% of that water. So over 1 million gallons of water will be returned out of that wellbore and be produced at the surface. What they're really doing now, most people are going to recycling that, reusing that on new wells.
Okay.
Some people have too much water, or they haven't recycled as much, and they'll dispose of that in what they call a disposal well. So you'll see, if you look in basically the literature and news articles, there's been a few cases of disposal wells creating small earthquakes in areas. So eastern Ohio is a good example. Oklahoma and Texas has a number of examples as well, where the water disposal from this, they're putting some water under pressure and putting it down into one of these sandstones at a certain depth, and they're around fault systems that they've basically activated or slipped in this case and created some small earthquakes. So that itself is an issue, is the potential of seismic activity from re-injecting waters, or potentially from, maybe from hydraulic fracturing as well. The issue here is we're actually trying to create these micro earthquakes anyways.
Right.
So we're measuring, they measure this all the time, and they know that the magnitudes are very, very low, way, off the scale, much lower than that what you'd see with an earthquake of sorts. But my thoughts are hydraulic fracturing, we fractured, I think over 1 million wells in the United States have been hydraulically fractured. In Virginia, actually, I got a map here showing, many are aware that Virginia is since the late 80s, we fractured about 6,000 wells hydraulically fractured in Virginia, mostly to produce out of coal seam. So these are shallower and really without much problems. To my knowledge, there's been very few documented cases. For the number of, there are obviously a few that have made the news, but for the number of wells that have been hydraulically fractured, it's a if you did a sort of risk analysis on it, this is very low.
Right.
But I think contamination at the surface is a issue in ensuring that there's proper wellbore integrity and sort of the rules that go with that. So I think this has brought out, sort of the environmental movement here against hydraulic fracturing, or looking into it more, has brought out better best practices by companies, and really making sure that, and it's I'm a mining engineer, and it sort of seems to be following the process that when you go through permitting a mine, that the natural gas companies are now doing, is that they're actually going out ahead of drilling and hydraulic fracturing to look at water qualities. So they are spending millions and millions of dollars, I've heard even more than that, some companies, to getting in front of where their development is, so they can test the waters, see what the quality of the water is, and everything from people's houses and homes and in the streams and that whatnot, so that after they go through, they can basically refer to that afterwards, so they have
sense.
Something to stand on, because the big issue has been methane in water.
Right.
And is it, and typically most cases, I'm not saying all, it has been basically from a biogenic origin, meaning it did not come from the Marcellus Shale, where all the methane that's held there is a thermogenic origin. So the biogenic origin is typically closer to the surface. So I'm not saying it wasn't because of the drilling in the area, but it could have been that it was just naturally there in people's wells when you looked at people lighting their faucets on fire.
Gas line.
Or it could be that the drilling itself loosened something up. It was maybe too close to the house. or too close to someone's water well. So having offsets like that from people's houses and water wells are